All right, and we're live, everybody. Welcome to part 4 of our near chain abstraction hackathon, scribeathon. If for the people watching from the very beginning, we have special guest Altan from the Near Foundation, and you guys should know by now Cameron on there. Cameron has a special announcement before we get started to let everybody know some pretty good news. Go for it, Cameron.
Yeah, so surprise, surprise, for those who have contributed to a lot of online hackathons, it's sometimes submitting on time can be hard. And so for those who are submitting, happy to announce that we are going to be delaying the submission date another week to February 4th at 8 p.m. Pacific. We'll be sending emails out to everyone today. We wanted to give everyone time because one, we're getting pinged, and there's no real reason for us not to delay. So yeah, just want to emphasize the new submission date is on February 4th at 8 p.m. And I'll be sending submission instructions today where you will actually be uploading your project on chain, and we'll be reviewing it all on chain because you can do this on here, and that's pretty cool. We're literally using the protocol to manage the hackathon. So yeah, just look out for that email. It should be going out later today. So that's all I got.
Just a quick note on that, because I know that the submissions are being due. I think we're collaborating on the Scribes Quest for the $1,000 Twitter thread contest. So because we're finding out right now, I'm going to see if any of those dates have changed as well for submissions on that. So let me find out. I'm going to start throwing some DMs right now as we go. If I get a response by the end of the workshop, if not, we'll make an announcement through the Twitter as well. So you got time, guys. All right. And so without further ado, data availability from Altan himself. We got a little confused last week, but this is it right here. We're gonna get some intro. Do you want me to share out the links for the slides on that one, Altan?
Yeah, go ahead.
Yep. Okay, and I'm gonna go ahead and add it to stage. Do a quick intro, Altan. Let us know who you are, what you do.
Sure.
Yeah.
Sure. Yeah, thanks for having me, guys. I'm Altan. A bit of background on me. I'm actually Turkish, grew up in Turkey, studied computer science and math. So these things like simulations has always been interesting to me. And worked in VR, actually, did some research in VR. And then found myself in a hackathon, actually. My story is quite interesting in NearCon to almost a year and a half ago. And then I won the hackathon, and just that's how I started in the foundation, pretty much from a hackathon to a full-time role. So it's always nice to kind of get back to hackathons and just tell everyone about this experience.
That's an awesome story. That's kind of like similar to my story, though I wasn't a computer science major. I was just messing around. I was like, oh, let me just learn this hack. And once I learned a couple protocols and SDKs, I was just hooked, and I just never stopped coding, and then just became. It's crazy how that works out,
Yeah, it's addictive.
Yeah.
Yeah, it's addictive for sure. Cool. All right,
So
let me. Should I kick this off? Yeah. So
yep.
So just to kick this off, really, we've launched near data availability last year in NearCon. So there's a lot of context of what near data availability means, but I'll just kick this off just by starting what near is, right? I mean, you've been probably hacking on near, but when we're talking about near as a layer one and sort of presented to other ecosystems, we sort of break it down into four S's, which is kind of simple. Near, if you've been sort of familiar yourself with near, is that you can build smart contracts with just JavaScript and Rust. It is written, it's written in Rust, so it's pretty secure. And then the whole thing about near when it was created was sharding. So it allows us to kind of shard the blockchain and increase these shards as we go. And obviously sustainability, but it's because we're just proof of stake from the start. By the numbers where we are really, these numbers are important because I'm going to link them to data availability and sharding and how those are important. But it can go up to actually 100 TPS if you add 100 shards. We currently have something around 16 million monthly active accounts. And just like what Cameron said, is that we've actually a lot of active developers building front ends and smart contracts too. So we've been sort of growing that number both on the monthly active accounts and the active developer side as well. And you can see that actually there's been 34 million accounts created and 16 million monthly actives on year. So chain abstraction. This is abstraction acts, obviously. So Near is transitioning more on the just positioning itself as a sort of the leader in chain abstraction. That's because there's a couple of different parts. We'll not get deeper into this. Mainly, the Near account model is super powerful to create chain signatures so that you can control different blockchain accounts from a Near account. But on the DA side, we kind of think DA is just part of the stack, and it will get abstracted for the layer twos, right? I mean, we've been working on that quite heavily over the last year, and you'll see us sort of integrate with rollup as a service providers, integrate with more of the stacks like OP Stack, Polygon CDK, anything that comes up as an SDK to integrate Near DA to abstract it for the developers, but also for the users as well. On this route of chain abstraction, we did a couple of partnerships, which is sort of like ZK Wasm Prover, which Near runs execution environment for Near is Wasm. So what you can do is essentially, since we're the Wasm experts, we kind of partner with Polygon to bring ZK Wasm, which essentially means on top of the DA, you can actually Wasm execution environments running sort of in a session like a ZK EVM, and then using Near DA posting the data there, and then finally settling on usually on Ethereum, since most of the rollup stack is built on there. We're actually building another sort of, going back to the data availability now, we're building a sort of a fast finality layer, which is essentially the problem currently is when you're settling rollups onto Ethereum, you are restricted with that 12-minute finality. What we can do is use eigenlayer validators, which brings up the Ethereum security, and then create a new layer, which we call fast finality layer, that can pretty much finalize transactions in 3 to 4 seconds. And then those transactions later on, kind of like a waterfall, go down to Ethereum for 12 minutes, but you can actually frame your transactions on that layer. And finally, going back to sort of getting a bit deeper into Near DA now. So it is a data availability for Ethereum rollups. You guys probably have heard of, historically, rollups used Ethereum as data availability. And now you've probably heard of Celestia being just a data availability, sort of like a blockchain, really. And then what we've realized over time, and I'll explain why, is Near is actually built very nicely for DA, and we sort of build a product, sort of like a smart contract and a couple of nodes to build a data availability solution. And currently, you can use this with the Starknet sort of framework and a couple of different sort of rollup as a service providers. And there's 3 stacks that are integrated. Hopefully we can do the 4th as well, which are Arbitrum Orbit, OP Stack, and Polygon CDK currently supports Near DA.
I have a quick question, Altan. On like, you're about to hit it right now on data availability. Like, I probably just stopping you right before you're marking it, but like data availability, everybody kind of like gets it confused as to what it actually is, right? Like when account abstraction came out, everybody's account abstraction, okay, but nobody knew what it actually was or did for a long time. And so, question about these, like when you're adding data availability to, like, with Polygon ZK EVM, and what is there a framework already in place for that? Like, is there an SDK that you can easily integrate?
Yeah. Okay. Yeah. So Polygon CDK comes with Near DA, so as OP Stack, just out of the box, really integrated. And the question, it's a pretty good question about account abstraction going into data availability. I mean, data availability is pretty simple to describe, but it's just kind of still a fancy world. It's just that all the participants in the network should be able to prove that data is there at some point in time, right? I mean, for OP optimism chains, it's way more important because you need to kind of retrieve that data. You need to run your computations and say, hey, this is fraudulent, and then go back and say, submit a fraud proof, right? So that's the idea. But simply, it's just like, it's just being able to prove that data is there, right? At some point.
And for the audience too, really quick, sorry to cut you off, Altan. If you have questions, throw them out in the chat. We'll bring him up to Altan on there. I know this is a lot of information to take in. It's really cool stuff, in general. Like, just this is new breaking stuff that people are pretty excited about. Like, just in general in the ecosystem space, everybody's trying to find a way to scale and do things. So definitely ask
Yeah.
away.
Yeah. So I guess going back to before we deep dive in, let's understand what modular stack is really. You'll hear this a lot. Like Celestia folks talk a lot about it, and currently it's been sort of the meta in all the crypto Twitter if you go around. It's that historically blockchains are monolithic, right? So Ethereum was built having sort of these 4 layers that outline in just one package. And what are those 4 different buckets? So execution is basically just like executing, taking sort of a transaction, processing it, right? Pretty much that means. And after that, when you think about settlement, which means sort of like settling a transaction, saying that the transaction is final and secure and it cannot be changed after that. Consensus is more about sort of having the transactions and ordering them in a block. And data availability means basically, if you do it really well, being able to access data at any time. So those 4 buckets are sort of like the pillars of the modular stack. And if you kind of like want to take those 4 terms and want to put them into sort of an order, this is usually how people sort of visualize it. Execution being on the top, settlement in the second part, consensus sort of the third part, and data availability is the fourth part. Because at the end, you need to come back to the data availability and say, data was there, and all of this has happened, and I want to retrieve that. Well, you might ask yourself, like, why do we need this? Well, if you're using Ethereum, I was using Ethereum yesterday to just to send a transaction. Really, I paid $10 for it, and the reason for that is all of it is just gets congested, and the more it gets congested, just the gas prices go up. So the Ethereum community's response to this have been historically launching things like Optimism, which takes Optimism or Arbitrum, taking execution out of the environment, which means sort of like building another blockchain to execute these transactions, and then doing all of that, all the rest of that on Ethereum. But the problem with that is still the call data, which is basically posting data on Ethereum, is still very expensive. And a lot of folks sort of started to think about how do we take data availability out of Ethereum as well to make the rollups even cheaper. So what are let's take that data availability out of the picture, but what are the current sort of like challenges that a lot of people face? The most important things are, it is pretty simple that people talk about throughput, which is sort of, it is the ability to sort of like put all of these, let's say 4 megabytes of data at the same time to a data availability layer. And it's pretty small for Ethereum. I think it's around like 200 to 400 kilobytes, as far as I know. This will change after proto-dank sharding, as far as I'm concerned, but it's still on the small numbers. And availability is obviously, even if a lot of people come at the same time and want to prove that data is available, will we have a problem, right? So that's another challenge, is that essentially, since rollups are sort of minimal numbers now, but if you go into the future and say, if I have 1 billion rollups and come in, try to get the data, try to prove that data is available, that is going to be quite challenging as we go forward. So there's still kind of challenges to be solved in the future. And there are currently 2 approaches to data availability. Obviously, when you think about Ethereum and obviously also Near, we take the data to the blockchain and we run that through all the parts I mentioned before, right? So you run it through execution, settlement, and consensus. And Ethereum does the same thing as well. And there are other approaches like EigenDA, which is basically sort of opting in Ethereum validators, but the data availability of EigenLayer is off-chain, meaning there's no blockchain that's been introduced for that. And The main thing to know about Near's approach is that we use sharding, which is sort of each shard. So Near protocol runs 4 different shards, and each shard has a data availability of 4 megabytes per second. And if you do the math, 4 times 4, actually we have 16 megabytes per second data availability, which means you can send 60 megabytes every second. And we can actually increase that. We will increase that over time. So New protocol team is working on increasing that to 6 different shards, I think, in Q1. So we will increase that to 24 megabytes per second. And just to sort of understand how sort of Near works is that sharding, meaning we shard the data, we split the data, we shard the blockchain, which means we split the blockchain into 4 different pieces, and so on. We can increase that after sort of to n number, really. And going back to rollups, really, well, and then linking that to different kind of rollups to data availability, there's obviously two different rollup types. Optimistic rollups, which is currently used by OP and sort of Arbitrum, is that they basically sort of take their transactions and put that onto chain, like onto Ethereum, and then somebody can come in and say, hey, I found something fraudulent, and I'm going to prove you that this is fraudulent, and then the data availability actually lives on Ethereum or other cases, or other data availability layers, really. So in that case, data availability for optimistic rollups is very critical, because you need to be able to retrieve the data and just say, hey, you've done something incorrect. Versus in the ZK rollup, it's more about sort of about more like price really related, because you really trust on the cryptographic magic that takes basically layer 2's use today. And what they do is, I have in that sense is just saying that I've done this state transition. Let's say you're at state n. You take all these transactions and you translate into state n plus 1, and you prove mathematically that you've done that transition correctly, and prove that on chain and send it to the layer 1. Yeah, why is that important? Well, there's a couple of questions that you can ask yourself why DA is very important for rollups. Obviously, the first one is verifying that every computation is correct. Secondly, there are cases like this happened before. For example, Arbitrum or others had sequencer failures. Sequences are just ones that sort of batch these transactions and then send them to the Ethereum layer 1. When those fail, how do we retrieve the block? How do we basically retrieve the blockchain and create it again? Literally, that's what it's used for. When you start to think about this a bit more deeply, you can actually build everything on a ZK-like sort of model. But the problem with ZK provers today is that they're very expensive, and a lot of folks sort of don't want to run them because of the costs. So how do you find the balance, really, right? You can do everything on ZK, but you really don't want to do everything on ZK because it's too expensive. But in the future, maybe that's where all the basically blockchains are going for. We're building sort of ZK native in Near protocol as well. And the other thing, obviously, to think about is that you can put all the transaction data, like the OP folks do on Ethereum, but you actually end up paying a lot of money to the Ethereum itself. And a lot of rollup providers actually make money on this arbitrage kind of opportunity where you run your own blockchain, you set the price there, and then you sort of pay some price to Ethereum, and you can make money on the sort of the difference. So why near DA, right? I mean, we explain a lot of the data availability. What does near DA mean? So this actually came up in our team where we realized this last year. We were looking at Near protocol, and we believe it's just sharding is one of these beautiful properties that Near protocol has. And how do we take that and introduce it to the rollups? That's how we started, and we started sort of digging deep into the performance of the Near protocol. So we've achieved roughly around 100% uptime with 4 different shards. We support a lot of accounts, meaning we do a lot of C transactions really on the L1, and then with that, when we're building and we're thinking about low cost L1, we also ended up building sort of every blockchain has a data availability, right? So like Near, Tezos, doesn't really matter. We've realized that we've built a high data availability layer with low cost data posting. So our thesis is that the reason we've made it very much cheaper and optimized is that we believe that sort of rollup operators eventually would switch to the DA that offers the cheapest option. And for that reasoning is coming from the fact that what I mentioned before is there's business opportunities to be made when you reduce the data availability costs. And when you look at the sort of the current pricing of Near DA, we actually get way more cheaper than Ethereum. It's almost like it's 85,000 cheaper than Ethereum to post data on Near. We also have we actually sort of cheaper than Celestia as well. And the gas model for Celestia is quite similar to Ethereum, which could eventually go up compared to Near versus we can still optimize the shards really to we can even optimize a shard for certain specific rollup to decrease the costs. So this is the current sort of pricing for data availability compared to some of the other folks that offer data availability. And the most important parts is obviously the data throughput also. You can just send more data onto Near and expect that to go through the consensus versus on the other blockchains, this might not happen. How does this work? So Near has this interesting consensus design, which is called Nightshade. So Nightshade is purely based on shards. And the cool thing about Nightshade is that just like rollups or other sort of blockchains that communicate, so if you think about layer 0, it is kind of like asynchronously communicating between different blockchains because every different blockchain has a different finality. What Nightshade does is actually it treats every sort of smart contract as a rollup in some sense, because when you send a transaction, if you're building on Near as well, you'll see this. You're actually sending a kind of a promise, like the JavaScript kind of way. You send a promise, and then you just say, "Hey, I'm going to do this transaction." Sometimes this transaction actually could go on to the next block, and you get a callback. So it's this await async sort of way of programming, if you are familiar with that type. And that's just purely built on Near versus if you look at Ethereum, it's very synchronous, right? So when you're reading state, you're actually reading the state pretty fast. But this basically design allows us to do just be more creative, really, with what we do with Nightshade. And the way sort of when you think about how shards work, shards just produce a small proportion of a block that later gets aggregator and becomes a block versus it's not like on Ethereum where everything goes to one block and that just gets sort of verified. And the cool thing about this is that the way we utilize this is if you send a function call to a smart contract on Near, on Near, there's sort of consensus around that sort of data, but it doesn't like fully go into the state. So what we do is, because we're sort of, if you're working with fraud proofs, which have sort of sometimes for people to come in and prove that that data is incorrect, our data sort of like the roll-up data goes to the state for 60 hours and then it gets removed over time. And so, but still it goes through the consensus from the validators. Validators still validate that. It's just that over 60 hours, we prune that, and we just want to make sure that the consensus is not bloated with roll-up data, really. And yeah, so if you want to prove that later on that this actually happened after that 60 hours, you can go back to the archival node and say, hey, I want that data. And this is actually built into our infrastructure, sort of our Near DA infrastructure to do that and to allow for a roll-up operator to come in even after 60 hours and say, hey, I want that data. And you get that data pulled back. So the way Near DA works has three important parts. One of them is basically what we call store blob data, which is just essentially a smart contract that takes pretty much the rollup data to near and runs that through all of the components that I mentioned before, right? So it executes, it's sort of takes it through a consensus, and it settles. The other interesting things is that it actually has two different sort of clients. You have a light client that if you go to Ethereum, I'll explain how that works. Today, you will see that the transaction that I send, right? If I'm a rollup operator, if I send that transaction to Ethereum, the light client's job is to take that and then sort of put that transaction ID to Ethereum. So on Ethereum, you actually store something like very small, like almost 64 bytes data. That's just like a small portion. So your costs are very minimized there. But also this light client, if the rollup operator says, is this really happened? You can go and prove that from the light client as well. And the RPC, the third part, is just the RPC that you can use for sending data to Near protocol. And the way it works for blob verification, it's pretty simple. You sort of take the Near transaction ID, as I've mentioned, from Ethereum. You ask light client that, can you please give me that proof? And then after you get that proof, you ask the light client, say, hey, can you verify that this is correct? And the light client does that for you. So I know this is a bit sort of very in depth of how NearDA works, but all of this sort of complexity is actually taken away from that user or the rollup operator. So if you go to Caldera, Dimension, or Arbitrum, or any of these folks, they actually would abstract that for you. They wouldn't show any of these and run those sort of run that infrastructure for you to kind of use it and guide you in the right way to build rollups on NearDA, which comes with, again, the chain abstraction vision of abstracting every complexity away from the user. The cool thing is, now just going back to, we actually had our first sort of today, our first rollup announcing that they're building on NearDA and OP-Stack, which, again, mentioning NearDA being very costly, very, very sort of cost efficient. They are building a sort of a fully on-chain gaming blockchain, which needs to do a lot of transactions. So when I think about NearDA, NearDA fits really well for any application that you're building that does tons of transactions, such as it could be DeFi, it could be gaming, which I know all of you, if you're doing fully on-chain gaming, you're really like keeping the state even of the game on a blockchain. So what's next? I think this is what's next.
Quick question on that for the gaming. Sorry to cut the flow. Is so based on the promise system that Near has, you're basically doing a bunch of promises that eventually asynchronously comes back and updates that state over time, right? Like, is that the premise of it?
Yeah, I mean, these folks are using still EVM, but that is correct, right? I mean, historically, we've had sort of the asynchronous nature just was one block, I think. So you kind of like send something and then you wait for the other block to execute a transaction. Mm-hmm. But as far as I know from protocol, you can actually do set time on these things. So you can say, hey, come 10 minutes later and do this execution. And that's very great for gaming, right? I mean, in gaming, you have a lot of timers. I mean, if you built a game before I did, in like Unity, you just do a bunch of different sort of, hey, like, come 5 minutes later and I'm going to do this transaction, really. I mean, it's not a transaction, but it's an execution of a code.
Right. Nice. I'm excited. I'm a big gamer, so like, obviously I'm an RPG gamer sometimes, so like, I can take the slow pace and wait my turn, but then when you play like an action game, I'm not sitting there waiting on transactions. And the idea of the asynchronous promises of like, I've done 15 transactions and that's going to reflect later, but I don't have to wait on it is pretty phenomenal on that. Yeah. I like the idea.
And the other cool is, like, before we jump in, what's next with NearDA, on Near, if you're building a game, for example, you can actually use the access keys. So Near's account model is access keys mean that once you give access keys can only call certain functions in a smart contract. So you can build them in such a way that I just gave this access key to you, and then you can just keep calling those functions on behalf of me. but if you do something fraudulent or something sketchy, I can just like turn you down with that access key. So it's kind of like account abstraction, which allows sort of like these primitives and these cool sort of contractions to be built on Near.
Yeah. Just for the people that are doing the writing contest, like the last 3 slides on this is like probably killer content for your, Twitter thread idea, just in case. It's really good stuff.
Yeah. So what's next, right? I mean, what's going to happen? I mean, DA, everybody has it's cool, like it's nice. I mean, that's what's going to happen. But so Near actually, Bowen, which is our head of protocol, had a very nice presentation in NearCon explaining sort of stateless validation, which is essentially increasing the number of validators on Near and then sort of decreasing the requirements to be a validator. So this is because we're actually thinking about introducing zero knowledge proofs to the some parts. I mean, we're not going to prove everything on the execution, but some parts we can introduce ZK proofs, which can allow us to sort of like not to store all the state in the validators, which increases the sort of hardware requirements. So that comes with a lot of sort of improvements, right? So we, as we go increase more sort of these validators, we'll be adding more sort of shards, helping DA, but also the blockchain really. And the cool thing about this is that and you see this with sort of Ethereum DA and also Celestia DA too. When you increase, look, they have this gas model, which means if there's a lot of rollups, you run into the same issues of very high costs for rollup operators. So what we can do is, as we kind of increase the sort of the rollups, we can actually add more shards, and that basically reduces the gas fees every time we kind of add. So that's kind of the powerful way of thinking about sharding. The other cool thing is that if this is a problem really, and if let's say there is a smart contract that consumes a lot of transactions. So you can see if you go to Near today, it's Sweat smart contract or Aurora smart contract. Like they get a lot of sort of transactions. What we can do is we can just like basically set the L2 to kind of like go to a certain shard and then have a specific RPC working towards that shard, because every shard is a blockchain, right? So you can kind of reroute all these requests to a certain blockchain. And that is just very sort of powerful. And then the RPC really, the light client, whatever, just only works for that shard. It doesn't work for other sort of things going on the blockchain. It can just track that shard. So that's pretty powerful. And the more sort of the validators come in, and actually the security of that sort of shard goes up as well. And that's we're quite excited about that. And we're kind of like thinking about the names for this, and it's still a bit rough internally, like how we're going to do this, because we're going towards a bit of a data availability roadmap for us, but it's probably going to be called data availability sharding. So that's what we're going towards in data availability. And the other things, I mean, we get this question a lot. Sort of, yeah, I mean, I mentioned this, rollups can rely on their own shard. And if there's interest, so we don't have currently data availability sampling, which is essentially what Celestia uses. Celestia just has a probabilistic method to say that this data exists 99% with certain confidence. We currently don't have that, but we have the sort of the primitives to build that, which is called erasure coding, built on the protocol. So if there's interest, we'll think about that in the future, but it's just not a sort of it's never been a requirement from the rollup operators that we've seen. And then finally, the RPC roads actually can act as a validators without actually participating in the fully consensus. So currently, like they participate in the whole blockchain's consensus, but they can actually be rotated and sort of focused on one shard. So that's where we are. Like we're thinking about sort of not only we're thinking about more like rollups being just kind of like shards, really, right? And if you treat them that way, we can actually offer some of the near stuff that we have natively to optimize that architecture. But that's the content I have for today. Pretty much explains everything from modular stack to near to sharding. So I know there's a lot to unpack, and happy to take questions.
Yeah, guys, if you have any questions out there, go for it. Throw it in the chat where you can share it on the screen. But I got to give you a shout out, Altan, because this is probably the best presentation that I've seen on data availability that made a lot of sense, that went into overall. And as soon as I was going to ask the question, the next slide answered my question. So I was like, it was a great flow. I'm like just sitting there with my mouth open, like, but it was really good. Okay, so Christian Rez is going to be typing it up on there. So SDKs to start using near today, right? So if I wanted to, like, you know what, I want to make a roll up on something, where do I go? Where can I start? Where can I read the docs on this kind of specific issue if I want to look at it? Because sometimes with docs, I'm reading a lot of stuff I don't care about. I just want to just roll it up and play with it. Is there a sandbox with it? Where can I go look?
Yeah, there's a near roll up. I think I can send it on the chat later.
Sure.
There's a roll up data availability GitHub sort of code that explains all of that, like everything that I went through. Yeah. And also we have like docs, basically how to deploy OP stack, how to deploy Polygon CDK, how to deploy Arbitrum Nitro. If you're really like burning to build a roll up, it's probably way better to go to roll up as a service providers, because they kind of like cloud, right? I mean, if you think about deploying an AWS server, I'd rather go to AWS to deploy that server than build my server myself. So that would be kind of the future of, like, Gateway, for example, has this single click kind of deploy roll up and kind of create that for you. So yeah, I mean, mainly those are the docs available, and obviously if you're in the near dev channel, if you have any questions, I'm more of a technical BD guy, but I'm pretty technical to kind of answer some of the questions. But if there's like super deep, I go to some of the folks that built it and ask them, oh, there's this question. But yeah, so we're available on near dev, and we also have the docs. If you have any questions, I can also take it from Telegram or anywhere.
One other question, as Christian's throwing that question up, like for the hackathon, right? What are you looking to see people build with data availability? Like, what would be a couple dream, like, that's a really cool idea to see executed or anything? Is there any like burning ideas you have in your head, or you're excited to see what people just come up with?
Yeah, I mean, data availability just doesn't depend on rollups. Like, it's something that, I mean, I'm trying to be creative here. Like, you can dump, like, I don't know, AI models on Near. You can dump anything on Real for using this contract. Like, this contract is the contract I mentioned is optimized for data, right? It's actually like, if you build your own data availability contract, it won't be as optimized as the one that I showed. Like, there's this blob data one. So, on Near DA, like, I'd love to see. I mean, we've been seeing sort of these gaming chains. Like, I'd really love to see rollups that have the nature to do a lot of sort of transactions, right? I mean, it could be, I don't know, this, like, games are a good example. Like, you can have just a game that used for a rollup because your game is fully on chain, right? It does everything on chain. Apart from that, like, pretty much it's very rollup specific currently, but if you have ideas to, I mean, you can also, the hacks could be like, if you've seen a new DA stack like ZK Sync or other ones, you can actually try to integrate near DA. Like, that could be a good challenge. The integration parts, you can try to integrate Cosmos into near DA, but that's too far. That'd be pretty hard. Yeah, so any like integrations are pretty much should be fun to integrate.
And we have a question right now, actually more of concern. The question, so if a chain wants to implement near DA, but for some reason stops paying, does the service go away? And I mean, the follow-up to that is thinking about, because Ronan just lost a major data provider and a bunch of the apps broke. And then this what happens with Avalanche when they stop paying Etherscan for go ahead.
So the question, I guess, like, if if data available, I mean, first of all, like if you're doing OP or if you're doing pretty much sort of the ZK WASM, the stuff still lives 60 hours on near. So technically it's on that 24-hour period. So it should be fine. But if your chain goes down, then if you need to make the history, you need to be relying on archival node. There are too many archival nodes on near, but it is a good concern, right? I mean, it is a good concern to say that's a business that could go away. How do we ensure that, right? I mean, to be honest, like I think we'll see more of these like incentivized RPCs, incentivized like nodes and things that actually incentivize people to run these things. But that's where also data availability sampling comes in, because you can prove that sort of certain things are correct. So the future roadmap would be implementing something like that, pretty much.
Nice. Basically, if a chain goes down, we got bigger problems than an app in a sense. Overall, yeah, definitely. And I don't think there's any more questions. Do you have any final words? Also, I'm just going to put a link to the Twitter thread contest that's happening. I don't 100% know if we're going to move the date extension on there, but I'm just sharing it out for people that may have just caught this workshop as the first time. We are having a Twitter thread competition, $1,000 USDC total prizes with 4 winners. So if you had looked at the previous 3 videos and then this video, you got a ton of content to base your Twitter thread off. There's a lot of cool things happening on Near that I really wasn't aware of until literally the workshops. And like, again, one of the best examples of data availability has been presented to us right now. And Cameron is coming back on stage to do a couple final words. I'm going to bring him back up and go for it, Cameron.
Hey, everybody. Yep. Just want to emphasize that this topic of chain abstraction is catching a lot of interest from a bunch of protocols. Polygon recently announced their chain aggregation initiative. Obviously, this has been something that's been in Cosmos for a long time. If you are new to Web3, like this is the thing to learn. This is literally how we're going to be able to honestly not care about what blockchain people are using, because people don't care if you're using an app on AWS or Azure or GCP. Like this is the Web3 version of that. Obviously, there's still really important considerations to be made when picking a blockchain to build with, but like if you're new to Web3, get to understand this stuff. Like I just can't emphasize that enough, because ultimately blockchains are just a piece to the open web, and this piece is actually getting figured out pretty quickly. So just hopefully some inspiration for new builders, because ideally this is the way it's going to go for a long time.
Your Twitter threads are going to be filled with all kinds of stuff about data. And you were seeing like blobs are coming on my Twitter timeline. I'm seeing all kinds of stuff, so it's definitely going to be a hot topic. And then once the influencers get a hold of it, it'll nonstop be on there about data availability on so and so. So definitely. So just a reminder for people that are catching in late, the submission date for the Chain Abstraction Hackathon has been moved to February, what, Cameron?
4th. So just the following week.
Yep. So one more week to get it all together. This is a great workshop to get inspiration. Definitely, we have all the other workshops on the YouTube channel. You guys are still have office hours and everything as normal in the Near Discord. So definitely got another week to grind it out. I will confirm and we'll make an announcement. I didn't get a response for the Twitter thread contest, but I feel like we should. Don't quote me on that, but I feel like we should to match the energy. But we will make an announcement and let everybody know. And so, yeah, thank you. If you guys have any final words, we'll just go ahead and wrap it up.
No words on mine. There was actually a pretty good Vision blog post that was announced recently by Ilya, who's the founder of Near and actually leading the foundation these days, explaining like the importance of chain abstraction. So I'm going to drop that here as well, because this is where things are going, not just for Near, but I think of all of Web3.
Yeah, I think the really great approach and why I'm really vibing with this is it's not like come to Near and just use Near. It's like for the betterment of the entire space. And like that, I vibe with that. It's like that. It's like, don't just come to our side. Like this is why we're doing it, but we're making it better because of this. And so I follow that tribe. So really, really digging what you guys are doing. Super cool presentation. Looking forward to see what people hack and see what people write about, like dissecting all this information. And letting me understand it in English terms sometimes. And there's one more. I'm going to go ahead and pull that out really quick and show that to the chat. And on that note, we're going to go ahead and finish it up. Much appreciated, man. Thanks, Altan, for a really, really clear explanation. Thank you, Cameron. It's been a pleasure. All right, guys. I'll catch you guys on the next stream. Hasta.
See you later.
Billy.
Bye.
Thank you.